Good morning, everyone. Today we are going to learn illustrates the six trigonometric ratios, which are the sine, cosine, tangent, secant, cosecant, and cotangent. So, the study of trigonometry as branch of mathematics concerned with the sides and angles of triangles, their measurements, and the relations between them. So, meaning we are going to discuss about right triangles or triangles. The process of solving triangles is used in such fields as surveying, navigation, engineering, astronomy, geography, and even in criminology. So in these disciplines, the fundamental concept of trigonometric functions are used. So let us first determine what is a right triangle. So the right triangle is a three-sided polygon in which it has one right angle. So as you can see in the figure, it has one right angle, two acute angles which are angle B, the angle B, and the angle C. The longest side and always opposite of the right angle is called the hypotenuse. The legs are the sides of the right triangle. So the legs are the two shorter sides of the right triangle. So this side are the legs. Side A, side B. And side C is always the hypotenuse because it is the opposite of the right angle. So in figure 1, as you can see in the figure 1, it is a right triangle ACB, where angle C is the right angle and angle A and angle B are the two acute angles. The hypotenuse of the given right triangle is side AB or the side C, and the two sides are the segment AC or the side B and BC or the side A. So these three uh, parts of the right triangle are important in this lesson. If the measure of one side of the right triangle is unknown, it can be solved using Pythagorean theorem. In this Pythagorean theorem, this states that the right triangle, the square of the hypotenuse, is equal to the sum of the square of the sides or the legs. In symbol, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse of the right triangle ACB. So, in Pythagorean theorem, if the side is unknown, we can use the formula c squared is equal to a squared plus b squared. So, example, find the length of the missing leg. So, as you can see in the figure, in this figure, we have the value of a is 4, the value of b is 3, and the value of c is unknown or the hypotenuse. So using Pythagorean theorem, we can find the value of c by substituting it to the given formula, where a squared plus b squared is equal to c squared. So substitute, the value of a is 4, the value of b is 3, and find the value of c. So we have 4 squared, 16, 3 squared, 9 is equal to c squared. Then add 16 and 9. So we can have 25. So 25 is equal to c squared. To find the value of c is we need to take the square root of both sides of c squared is equal to 25. So we are going to use square root. Square root of c squared is equal to the square root of 25. And the answer is c is equal to 5. So we can have the value of the unknown side, which is the hypotenuse side C. Another example is, in this case, or in this figure, we have the value of C is equal to 10, the value of A is equal to 8, and the value of B is equal to X, or the unknown. So in this case, we are going to use the formula a squared plus b squared equals c squared. So substitute, we have the value of a is 8, so 8 squared plus the value of b is x. X squared is equal to 10 squared, which is the value of c. Then 8 squared is 64, x squared, still x squared. Then 10 squared is equal to 100. Then, to find the value of x squared, we need to subtract both sides of the equation by 64 to eliminate or to isolate the x squared. So we have 64 minus 64 is 0. 100 minus 64 is 36. So we have x squared is equal to 36. Then find the value of x by taking square root of both sides. So square root of x squared is equal to square root of 36. And the value of x is equal to 6. So this is how we solve for the unknown part of the right triangle by using the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Next, we also have the two special right triangle. The first one is the 45 by 90 right triangle, which is also known as the isosceles right triangle. And we have the 30, 60, 90 triangle. So these two triangles or right triangles are special because there is a exactly value of each sides. So the isosceles right triangle theorem states that in 45 by 45 by 90 triangle, the hypotenuse is square root of 2 times as long as any of each leg. So as you can see in this figure, the value of side A is equal to A, and the value of side B is also equal to A because these two sides are congruent. Then the value of the hypotenuse or the C, which is opposite of the right angle, is A square root of 2. So if the value of A is equal to 3, therefore the value of B is equal to 3, and the value of C is 3 square root of 2. Then another special right triangle is the 30 by 60 by 90 triangle theorem. It states that the triangle or the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times the shorter leg. So in this case or in this figure, you will see that side A is the shorter leg, side B is the longer leg, and side C is always the hypotenuse because side C is the opposite of the right angle. The shorter leg is adjacent to the right angle and also the longer leg is adjacent to the right triangle. The opposite of the shorter leg, the opposite angle of the shorter leg is always the 30 degrees and the opposite of the 60 degrees is always the longer leg. So the formula A is equal to A, B is equal to A square root of 3, and C is equal to 2A. So sample, if A is equal to 5, therefore B is equal to 5 square root of 3. And if A is equal to 5, therefore side C is equal to 2 times 5, which is 10. Next, we have trigonometric ratios. It is important that we can determine which between the two legs of the right triangle is the opposite side or the adjacent side. The side opposite to the given acute angle is the opposite side of the side which forms one arm of the right angle is the adjacent side. So in this given figure, if the given angle theta, this is the angle theta, this angle is the angle theta. So therefore, this is the markings where will you find the opposite side, the adjacent side of the given right triangle. So if this is the angle theta, therefore, the opposite side is the opposite side, this side. Then the adjacent side is this side. The hypotenuse is always the longest side because it is the opposite of the right angle. Okay, in this figure 4 shows that the right triangle ACB, so we have ACB is a right triangle because of the markings of the right angle with respect to the acute angle A. So this is the angle theta. The angle theta is in the angle A. So therefore, the opposite side is side BC or side A. The adjacent side is side B or segment CA or AC. And the hypotenuse is always the longest side, which is BA or side C. So the six trigonometric functions of the right triangle are the sine, cosine, tangent, cotangent, secant, cosecant. So with respect to the acute angle, the angle theta of the right triangle, each function can be defined by the following trigonometric ratios, and it can be easily determined or remembered using the mnemonics SOHCAHTOA. So SO means sine, O means opposite, H means hypotenuse, C means cosine, A means adjacent side, H means hypotenuse, TOA or T means tangent theta, O means opposite side, A means adjacent side. And the other function, we have the cotangent, adjacent over opposite, secant theta, hypotenuse over adjacent side, cosecant theta, hypotenuse over opposite side. So in this case, using this figure 4, if you know the opposite side with respect to the angle theta, If you know the opposite side, the adjacent side, and the hypotenuse, we can now determine the value of each trigonometric ratio or functions. So, using side A and side C and side B, these are the trigonometric ratio. So we have sine A is equal to A over C, cosine A is equal to B over C, tangent A is equal to A over B, cosecant A is equal to C over A, secant A is equal to C over B, and cotangent A is equal to B over A. Then, here is the example. So, in this given example, the angle theta is here. So, therefore, the opposite side is this side, which is 8. And then, the adjacent side is this side, which is 15. And the hypotenuse is equal to this side, which is 17. So, if you know the parts of each of the sides of the triangle or the right triangle, which is the opposite, which is the adjacent, and the hypotenuse, we can now determine, or we can easily determine, what are the ratios. So here are the ratios of the trigonometric function. So sine theta is equal to opposite, which is 8, hypotenuse over 17. So 8 over 17. Then cosine theta is equal to 15 over 17. Tangent theta is equal to 8 over 15. Cosecant theta is equal to 17 over 8. Secant theta is equal to 17 over 15. Cotangent theta is equal to 15 over 8. So, this is how we illustrate the 6 trigonometric ratios: the sine, cosine, tangent, secant, cosecant, and cotangent. So, for more information, here are the steps that we may consider in looking for the trigonometric function or the trigonometric ratio. So, letter A, look for the trigonometric function where its trigonometric ratio or value can already be determined. Then B, find out the unknown sides. So, in finding the unknown side, solve the unknown side using Pythagorean theorem, which is c squared is equal to a squared plus b squared. Then substitute the values of opposite side, adjacent side, and the hypotenuse to find the other functions. So, thank you for listening and watching my video.